Everybody, and welcome back to Let's Play Universe Sandbox. Now, as promised, in this video, I'm going to show you the different ways that you can play around with this game. So, just to start off, we're just going to place Earth there, and I'm going to put another one here. And if I speed it up, you'll see that the two will eventually start to orbit each other before they launch into space. Oh, they are actually going to stay in an orbital path. That's interesting. Whoop. There we go. And what this waggy tail thing is that that's the gravitational path that it may or may not take. That's interesting. Now, I've actually played around with this, and I made like line art out of planets. So let's pause this. And let's get some moons. But I have had a lot of fun with this in the past. Just have to line this up right. Okay, 4 moons. And they will all start to orbit. Now, eventually they will collide with each other if one of these is even a fraction off. But I think it's working. I think I placed it close enough. I don't know, that one's kind of off. Yeah, I think that'll work. Okay, now I'm really going to mess this up when I do this. Let's put one just outside of its range. And then I want to edit this. And I'm going to drag it down. Whoa, okay. There we go. Drag it down. Drag it over. I need to get it right intersecting with Earth. Okay, that's pretty close. Yeah, let's go with that. Now that's going to mess up a lot of gravitational force here, and you can actually see that it is affecting the path that Earth is taking. So now instead of just sitting still, it's going to start wobbling around, and you can see that it's really affecting the other moons now. So this is a good simulation. This is a good way to explain just how sensitive the universe is. You throw one thing off, you throw everything off. It's not even working anymore. Okay. So I can show you this too. Let's go 30 seconds per second. Whatever. It's good enough. Place that there. And you get a list of actual black holes. Whoa. Now look at how tiny this little guy is, right? I'm going to place him, let's say back there. And the Earth is, and look how fast the Earth is already traveling towards it. It's not having a good time. It's about to have an even worse time. And Earth's gone. I blew up the Earth. Oops. It's kind of like it's even of everything. And no, dark matter is not a black hole either. I've heard that in the past. They are completely different. I can show you guys some planets I have actually made. So first thing I need to do is place a sun so that it's nice and warm. It does come with this thing called a zone. And what this does is the red ring is way too hot. It's where Mercury and Venus is. Earth is right around the path where the red and green meet. It's a little bit more in towards the green. But the green means it's viable for life, and the blue is just far too cold. Now let's go to user objects, and I believe I placed it right here back when I made this. And we are sitting at 264 degrees Celsius. I'm going to have to speed this up. Yeah, see, it's frozen right now. It does have an atmosphere, but because we're close to the sun, it will eventually warm up. So let's fly through time. And I may have even placed it too close. I'm not real sure. Yeah, I'm a hair too close, because I remember when I made this, it was sitting at like 22 degrees Celsius, but this still works. It's not too hot. But that's the planet oh my gosh, that's the planet I made. I think it's pretty. Now the color is because it's a lot of iron. It's the same size as Earth, but the density is far higher, but it's still viable for life. We have water. We have an atmosphere, clouds, it does have weather, it has a climate. So I can show you another one where I terraformed Mars. I'm going to place Mars over here. Speed up time a little bit. Okay. Because I have to warm Mars up now. Whenever you place something just randomly, it will start off extremely cold. Might be way too close to this. It's probably going to dry itself. So let's pull this back a little bit. Okay, it's getting better. I don't remember the exact distance from the sun that I placed it, so I'm just kind of guesstimating here. Okay, we're almost there. Alright, I think that's good. It's probably going to stop around 18 degrees Celsius, so as an average temperature, it's not bad. It's definitely livable. Now you're still going to have the red surface because all of that oxidized iron has already rusted, which causes the red tone to the planet. But it has clouds and it has water, and in probably a couple thousand years, maybe not even that long, you would have to work with the oxidization that caused that rust, but you could definitely live there within not a human person's lifetime, but within the time of the human race. We could definitely do it. Nope, I didn't want to do that. Hold on. Something else that you can do if you just want to play around. Oh, real quick, I'll show you this. The size charts of everything are dead on. So that's our sun, and this is the largest sun known to us. I want to pause this so they don't run right into each other. But I mean, this little guy here is our sun. That little guy. And that is the largest sun known to us thus far. It's huge. It's massive. It's big. However you want to word it, it's awesome. And again, I love the music on here. Something else you can do are place actual objects. And for any Doctor Who fans out there, I'll just throw that in there. Okay. Yes. For all you Doctor Who fans out there, I'll just throw that in real quick. I didn't mean for them to orbit each other, but let's place this. And something you can do is you have this little launch button right here. You can just launch things into each other. Whoa. What happened? Everything is launching quick. Oh, I need to slow down, that's why. Nope. No, it's just gone. Yep, I'm just launching it into space. Okay. I didn't mean to do that. Now there's just pyramids flying all over the place. Exit edit mode. Stop that. Okay. Orbit. Yeah, there we go. And now, on things like this, there is no physics to it. They just kind of simply absorb each other and keep growing. It's going to be one big pyramid. I could sit there and do that all day, and it'll probably eventually be bigger than Earth. You can put things as small as dice in here. Boop. Little dice. Stick a marble next to it. Stick a pumpkin next to that. Oh. I didn't mean for that to happen. Oops. Yeah. I wonder if anybody has ever played pool in this. I have an idea. You're gonna have to give me a minute, but I have an idea. Didn't mean for it to do that. Okay, so for all you pool fans out there, I know I didn't set the balls up right. I play pool all the time. I know how it's supposed to go, but just bear with me. Stripe solid, blah blah blah. I at least got the 8 in the center, okay? So, now, I have this on still. I'm gonna go to launch. Is there a cue ball? There is, thank goodness. Right. Nope, they all just absorbed into everything else. Why did the 11 win? Why specifically the 11? Well, I'm sure there's a way to do it, and I just don't know how to. I wish that they would even give you a pool table. That would be pretty. What happened? Ooh. So I just launched a random bowling ball into space. Oh, and there's the cue ball. Wow. Okay. Anyway. Nope. Okay. But there's so many different things that you can do in this. Again, the only limitation is pretty much your own imagination. Yeah, that sounds cliche. Whatever. Oh, shoot. One of these are going to go supernova. As soon as they collide. Woo. It's kind of cool. It's like you're painting with light. Can you imagine if stars actually did this? And I'm sure somewhere out in space, this is actually happening. Maybe not at that speed. Hopefully not. Potentially not. That would be kind of scary. Here's Planet 9 for everybody. I don't know if you guys have heard about Planet 9 or not, but that gives you a size comparison. That's why they actually said, hey, Pluto's not a planet anymore. And then they found a 9th planet, which is way outside of the solar system. Just so you guys know just how far this is, this game actually has a simulation on it. That's going to take... Okay, so now there's just hydrogen floating all throughout space, which is probably going to create other gas giants at some point. But we are now 24 times the mass of Jupiter, and the radius is much bigger, so it grew a lot. So let's increase the mass, and you can just do this physically too. So now it's 50 times the size of Jupiter, and the radius is still increasing, the density is still increasing. This is, let's do kilograms. I know kilograms better. Let's just up this to 100,000. There we go. See, now eventually, if you add enough hydrogen, add enough mass, and increase the density, it will implode and either become a star, or I'll skip right over that and it'll become a black hole. Either one. Still holding. I'm shocked. Let's do 600,000. Wow. Mass is holding though. Let's do 1 million. What? Alright, let's increase the mass to 100. Okay. We are now superheated. This is actually exactly what I wanted to show you guys. We are superheated. The density is insane. The mass is insane. No, let's do 150. Oh, something's happening. This is actually the first I've seen that. I'd have to say it's not good, but wow. Alright, now let's increase the temperature. Surface temperature is 976 Kelvin. Okay. Alright, so it was a star, it was just an extremely cold star. We were at 702, which is that color. Now, over time, I'm only doing this by half an hour per second. And I believe what that is, it's actually... That is so neat. Look at that thing. I believe those are solar flares. If I'm probably wrong, but if I'm not. Now let's increase it to 1,000. And you will see that the hotter it gets, the more it burns, the more it burns, the more it glows. I don't know why I say glows, the brighter it gets. Let's go to 2,000. Let's go to 2,700. This is close to where our sun is. Now this one is much smaller though. Yeah, much smaller. There, same size as the sun. The density is insanely higher, and the mass actually dropped a lot. So let's do that. Yep, look at that. Oh, where'd he go? Okay. Now, eventually, for those who don't know, it will turn blue. That's a white dwarf at the moment. I think it's at 10,000. There we go. So how cool is that? I'll max it out at 12. How cool is that? Let's slow this down a little bit. And we'll get a real good close look at it. Now, all these little circular pockets you're seeing, if I reduce the density and the mass, that'll actually decrease a lot. Oh, nope. Oh, shoot. I didn't mean to do that. I went back into planet form. The mass wasn't high enough. There we go. Anyway. Now, I might be able to turn this into a light pillar if I remember how to. If I remember how to. I'm not sure if I remember how to. Life likelihood 0. I can't imagine why. I don't remember how to do it. Okay, hang on for 1 second. I'm going to figure out how to turn this into a light pillar. So while I'm sitting here researching light pillars and all that, I looked back up to my computer and saw this amazing solar flare that I definitely wanted to show you guys. And you can actually see that this sun, this star, is expelling and taking back in atmospheric pressure. But look at that. Look at that. That is so cool. I just wanted to show that to you guys. I just thought that was so fascinating. So this is what I came up with. I figured it out. I actually had to adjust the magnetism on it. But what happens is that the sun undergoes serious change and actually affects the magnetic fields. That is, in fact, so dense, it changes the direction of light. So it's coming out of its north and south poles and around the equator of the star. But that is a light pillar. And I absolutely had to be sure to show this to you guys. And this is second per second. This is real time. And you can just see the light flowing out. Granted, it's a little glitchy, but my computer is very low on rendering. But it's just absolutely fascinating. I love it. I hope you guys really enjoy it. And I'm going to end this episode here. If you guys want to see more Universe Sandbox, there's a ton of other things I can do. I can launch things at the speed of light. I can collide things together at the speed of light. So there's still plenty that I can do on here. And it's so much fun. If you guys want to see more, just let me know. But please be sure to comment, like, subscribe, and you will definitely see more in the future. But until then, I'll see you guys in the next video. See you later.